Now I have a distinct honor. I've never done this before. This is a first for me. I've had lunch with Nobel laureates. I introduced William Shatner once, but I've never actually had the honor that I have now to introduce a Nobel laureate and his presentation. Professor Reinhard Genzel from the Max Planck Institute for Extraterrestrial Physics in Germany. I could give you the list of awards and honors that Professor Genzel has received, but I think the time is short and we're here for a very specific reason. So I see you. Thank you very, very much, Professor Genzel, for joining us, and we all are very much looking forward to hearing from you. Thank you.
Well, thank you very much, Oded, and it's a great honor for me to participate in this session. My dear colleagues of the Academy, I apologize that I cannot speak in Hebrew. It would have been a pleasure to do this, but let's do it in English. I've been working here in Germany as a director of the Max Planck Institute now for 36 years. I'm an experimental astrophysics researcher. I have a sizable group of people. They're doing work in infrared, sub-millimeter, millimeter, and radio astronomy. And we're building our own instruments. So for us, experiments is a very important part of what we do. We study how galaxies evolve, how stars form. And lately we've been very much concentrating on the issue of whether indeed black holes, as proposed by Einstein 100 years ago, do exist in the real universe. And as you may have heard, over the last 10 years or so, from 3 different directions, gravitational waves, our work, and also from radio astronomy, the evidence has come now in that indeed Einstein's theory does apply to these objects we call black holes. ESO has played an enormous role in this. I should also say that since about 30 years, I've been in the lucky position to work with 4 Israeli institutions and colleagues there, Tel Aviv, Jerusalem, Weizmann, and Haifa. And there's no doubt, in my view, no doubt at all, that ESO and European astronomy associated with it would benefit enormously from having the Israeli community participate in this endeavor. Now let me now share my screen with you to explain a little more why it is so important. Of course, ESO is a relatively new organization, as you will see in a second, but arguably now, and certainly in the future, it is the best ground-based optical infrared facility in the world. And it is so, as I will explain to you, because ESO has managed to allow different cultures and different communities to bring in their expertise and work together in an international way. Now, of course, you know that in many ways, if I want to make it short, the astronomy on the ground in optical and in the near infrared has had its first major milestones in the US. There was a period, of course, before in the United Kingdom, but let me skip that. Certainly in the 20th century, the 100-inch telescope, so-called Hooker telescope on Mount Wilson was sort of the first generation of these big telescopes. This was the one where Edwin Hubble detected the expansion of the universe. And the United States, and California in particular, has had a role of leadership in ground-based astronomy for many years. The second big one there is the 200-inch on Mount Palomar, where quasars were discovered. Quasars, which we now believe to be very massive black holes, accreting enormous amounts of material and then radiating that away in terms of optical, radio, X-rays, and so forth. So throughout the first part of the 20th century, I would say it's very clear that the leadership in ground-based astronomy was in the United States of America, and in Europe, most of the national facilities were just not large enough. There were several, all the big countries had them, but they were small, and they didn't have the power to compete with the United States. Now in 1962, the first treaty intergovernmental organization, ESO, had about 10 member states and came together, and they decided wisely to put their first telescopes on a site in Chile, on La Silla, and try to there bring and focus the efforts of European astronomy. Initially with a small telescope, then came a 3.5 meter telescope, which was the biggest one at the time, but internationally not all that impressive. The key thing about ESO, which nowadays, in retrospect, makes it very different from the US facilities, is, as I said before, the international collaboration, the strong multi-institutional participation, and that allows to bring into the astronomy observatory strong multi-institutional participation in the development of new technologies, industrial activities, education and outreach. And I think you hear this list, and I could elaborate on this, and it's clear that Israel has a lot to offer there for the future, whether it's in computing or fine sensing. It's very clear that these kinds of capabilities make the core of the technology progress in astronomy nowadays, which has allowed over the last 50 years to turn astronomy, an old field after all, into one of the most active fields of physics of the last 10 years. 4 of the Nobel Prizes in physics went into astrosciences. That's pretty outrageous because Nobel himself at the time, actually in his will, prescribed astronomy to not be part of the reach of his prizes. So ESO now runs 2 sites. The first one, La Silla, the second one, Paranal, and I'll describe that more. A third site, Chattanooga, is the site of a world telescope, a millimeter sub-millimeter world telescope, where not only Europe, but also Asia and US, Canada are participating. But certainly Paranal is the premier site, best site in the world in terms of clear nights, seeing an atmospheric transparency. Paranal has on its 2,600 meter site 4 8-meter telescopes. That's the largest number of large telescopes currently in the world, plus two somewhat smaller survey telescopes. Now these 4 telescopes each are equipped with specific instrumentation, which makes it unique in terms of the overall complement of capabilities. From optical spectroscopy, UV spectroscopy, to high resolution near-infrared, mid-infrared imaging, so-called adaptive optics, including with lasers. All of this is there. And the key thing is most of these instruments were not built by ESO, but they were built by institutions in the ESO member states. Initially, more in smaller consortia, nowadays typically in groups of up to 10 institutes. And these institutes then get guaranteed time. We've been building about 25 instruments for ESO in my 36 years here at MPE, and I have to tell you that this possibility of bringing the most efficient new technology to this site and then put it on the telescope was the core of our success. And the guaranteed time was a key part of this. In fact, I should say, and I make one more comment on this, a key element here is that not only can you observe with single telescopes, you can, and we've made that our goal of the last decade, bring the light of all 4 telescopes into an interferometer with an equivalent resolution of a 100-meter telescope. That's unique in the world. And indeed, as you heard from Coded already, this has lately resulted in the fact that ESO is produces the largest number of scientific papers of all observatories other than the Hubble. And indeed, very unique in all different fields of astronomy. And a number of highlights can be tied to the ESO progress, whether it's the black hole in the galactic center, exoplanets, expansion of the universe, the structure of protostellar disks, and the explosions of stars, etc. So it's been enormously successful, both in terms of the number and the breadth of science to the individual communities in Europe participating here, but also in the key excellence results which are worldwide visible. I don't want to by any means diminish what the United States has done lately. The Keck telescopes also have been very successful, but I would say, at least with the VLT, nobody would disagree. The VLT is in the Champions League, and perhaps now, in fact, in the top of the Champions League. In our case, let me just make a few more remarks about the interferometry. We have built an instrument called Gravity, which, as I said, combines the light of all the 4-meter telescopes. And we've used that for a number of groundbreaking results, testing general relativity in the black hole in the galactic center for like a laboratory on Earth, seeing the environments of distant black holes and measuring their masses, looking at star-forming regions and seeing the multiplicity of stars, looking at the spectra of the planets outside of our solar system and measuring their atmospheric content, and many more things. And it's clear that interferometry now is one of the major goals. And it's clear that the ELT, about which I will speak next, will continue along this absolutely fantastic road of discovery. The parallel mode is, of course, that ESO builds the telescopes and maintains and builds up the infrastructure. But as I said before, very, very important, the instruments largely are developed in partnership with in consortia, then given to ESO through a fairly professional system, and then operated by ESO and the consortia who have delivered these instruments then obtain guaranteed time. ESO is a very efficient professional institution in an incredibly good site. There's no other site in the world which compares to this. We had for a while a collaboration in the United States on the so-called Large Binocular Telescope, which we then gave up a few years ago because the efficiency of getting good data in Arizona, which is known to be a very, very good site, was about a factor of 10 or 20 worse than Chile. Chile is the best ground-based astronomy site in the world. And indeed, the next big step is on its way. The largest telescope which is being built is a 39-meter telescope, the extremely large telescope with all equipment, adaptive optics, and many instruments on a site which is a mere 25 kilometers away from Paranal, slightly further inland, and will be operated from Paranal, thereby making the costs less. Now, the ELT of ESO in its conception was actually later than two American telescopes, the so-called 30-meter telescope, the TNT on Hawaii, and the Large Magellan telescope, also in Chile. Unfortunately, and that's a key thing you should keep in mind, astronomy has entered now, in a way, the particle physics type size of experiments. The ELTs cost between 1 and 2 billion. That's just like big satellite machines. Individual university groups cannot really very efficiently participate in this. You have to have a more professional, longer-term structure, and ESO can do that. And fortunately, Max Planck Institutes can do it. And if Israel would participate, I would advise you to create a structure within Israel that can work together and focus the activities which you might want to do with the ELT and the VLT in a single system which can act in a professional engineering way. That's the ELT today. It's first now of all the ELTs, and probably by about 7 years. That's incredible. This is the situation. You see the site with the dome being built up on also the platform where the telescope will be. So we hope to have it in first light in about 4 years from now, and it will be equipped initially with 3 instruments, an imager, an integral field spectrograph, and an mid-infrared instrument. Our institute, MPE, together with another, 6 other institutes in Europe, is building the first one, Mikado. You see the size. These are gigantic machines, all equipped with laser guide star adaptive optics to get the high resolution of this telescope, which will be on the order of 10 milli-arcsecond in the near infrared. Then there will be more instruments coming later, which are being worked out, also high resolution multiplex spectrographs, and then of course cameras which should image and resolve exoplanets. So ESO is a facility which I would say is in excellent shape because the stability of a multinational organization, it is not dependent on the whims of the ups and downs of the economy of a single country or a political party. And although this might add some sluggishness to the operation, it ensures stability of doing fantastic science, which in astronomy is now, I would say, guaranteed to go on for another several decades. Thank you very much.
Reinhard was modest and he didn't emphasize this himself, but, of the last 4 Nobel Prizes, 3 went to discoveries that are directly relevant. I mean, they're not even relevant. They are the subject of investigation that ESO is committed to. In 2017, gravitational waves, finding their optical counterparts and measuring their spectra will be entirely something within ESO's capability. In 2019, exoplanets, and in 2020, Professor Genzel's discovery, along with others, of the black hole at the center of the Milky Way. All of these things are at the heart of what the ESO mission is. So with that, I can, if you're willing to entertain a couple of questions.
Sure.
Please raise your hand, and I'll repeat them back. If anybody online wants to ask a question, please type it in. Any questions from the audience? Ken? Yes, Danny.
Hi, Reinhard. This is Danny. Can you hear me?
Danny Maoz is asking a question.
Can you hear me, Reinhard?
Danny, a little hard. Can you go closer to a microphone?
Maybe I'll...
You can come up, yeah.
Can you hear me better now?
Yeah, better.
Oh, okay. Of course, to join ESO, then ESO has to accept us first. So would you have any advice for us on how to best approach ESO and to make this succeed?
Danny, that's a very good question. As you well know, the possible coming in of ESO was discussed already a decade ago in a more informal fashion. I think now is a very good time. For once, it's clear that one or the other dollar is missing in the construction of the ELT. And mainly, I should say, because of two things. One is the pandemic, as it. And the second is that one of the contractors, namely the company which is doing the dome, was the same company which built that bridge in Genoa, which collapsed, as you know. So there's a tightness of funds. But I think more importantly, I would say this is a unique opportunity in particular because it's, the need for analysis and computing, for which your community is so famous for, would make these facilities of ESOs even more competitive. I can tell you that at the council level of ESO, which my colleague, Dr. Linda Tacconi, is sharing right now, there's a lot of sympathy for you. And I can also tell you that I will do my best if you want me to speak for you.
Well, we couldn't have asked for a better vote of confidence. Any other questions? Avishai? You can come up if you don't have the mic. Introduce yourself.
Hi, Reinhard. Avishai Galiam from Weizmann Institute. Sorry.
Hi.
Hi. Your group is famous for building instruments that were cutting edge and instrumental in so many discoveries. And I think looking to the future, if Israel joins ESO, this is one of our goals to develop such capabilities also here. So can you tell us a little bit about how to go about, how you went about doing that, what sort of funding is you will manage to organize to support such activities, and any other advice that you have on this subject?
Well, of course, at Weizmann, you already have a fairly sizable structure, but as I suggested earlier, you might want to look at a structure Israel-wide. Because one of the, if I may say so, and please don't take it in any wrong way, one of the somewhat disadvantageous parts of the Israeli community is that it is so spread. And it would be very good that you speak with one voice. And then if you agree that you want to participate in one instrument, say, that you really do this full force and with the support of all the different universities and organizations. So you should, in my view, look at just a joint organization, whether that must be a localized facility or could be virtual, I have no.
Okay, great. Thank you again, Professor Genzel, for taking from your very precious time and for sharing your perspectives with us and for your vote of confidence. And I'm sure we'll be in touch more about this in the future. So thanks very much.
Okay, wonderful.